All right. Hello, good morning, good afternoon, good evening. It's your Monday show. Welcome to another unscripted .NET entertainment. Our mission is to empower the .NET community to achieve more. I'm your host, Myra Wenzel, with my co-host, Cam Soper and Frank Boucher.
Hello,
And I'd
hello.
like, yay! And I'd like to welcome today's guest, Daniel Costea, who's going to be talking about Agentic AI. Daniel, how about you introduce yourself to our audience?
Yeah, I'm a Microsoft MVP on .NET and AI technologies, and I'm a developer for long. But of course, I had a chance to go through different times, different paradigms, and now again the paradigms are changing. So I try to stay up to date, and of course, I had to choose because many years ago, when it was very big hype on front ends on Azure. Somehow I was not quite um, caught by this. So when deep learning and machine learning popped up, or they became more mainstream, then I made the move. And now, because why not? Generative AI, it's very exciting, and probably why I like the most generative AI, it's because you don't need much data to start. For machine learning and deep learning, you need data sets. If you don't have data, then there is no fun. So generative AI was a very good opportunity, especially when semantic kernel, the alter ego of a Microsoft Agent Framework was launched. I simply got in.
All right. So cloud wasn't much your thing. It was AI that pulled you in. You still have need both, right? Like in today's world, you cannot have not
Absolutely,
have
but
that.
not like a passion,
Yes, I know,
more like a
totally get it.
necessity, indeed.
All right. Do you want to pull your slides and get started?
Yeah, sure. Thank you. So I will get started. So I will discuss about small language models from um, Microsoft Agent perspective or vice versa. Um, First, I want to let you know that I'm writing a book. I had all my 16 chapters ready. Actually, they were in process of reviewing when, guess what, 1st of October came and hit me. But for a good reason, because now, after almost a month, I can tell Microsoft Agent Framework is even better. So, of course, I'm in the process of migrating the old book to the new book with many publications, and I'm working hard with the editors to migrate the code repository and to review the chapters and get it done as soon as I can. But today I will discuss about how we can use agent framework with self-hosted models. Why I find this important? Because you don't have all the time access to internet, or simply put, your data cannot go out of the organization, or many other reasons. But I think this is the most important. So as I said before, Microsoft Agent Framework is unification of semantic kernel with with autogen. So it simply takes the best of both, and it's even more. Under the hood stays the beautiful Microsoft.Extensions.AI library, along with some providers which are already available to use. And I'm talking here about OpenAI, OpenAI, and Ollama. Soon we'll follow some other. So having this about internal architecture, let me remind you what makes an agent. Because if we have a query we send to the AI model, we cannot call that an agent yet. It's more like a chatbot or something else, but chat completion, but not an agent. In order to have an agent, we have to have some memories. We call this context. And we have to have some tools to perform some actions. We don't want to get stuck with with our work in a model. So we want to take actions. But instead of getting the result, we can have this out of the box by design to have the built-in tools which are powers or skills which the model can use and assemble for you a better result. And of course, we have the providers, which are the way the application, the client application, connects to the large language models. Let me show you a little bit the flow. So we have the agent. We prepare a prompt, which is our input, and we expect the result. Well, we send the prompt to the model, and then we expect the result. But this is a stateless agent. I mean, it doesn't have memories, it doesn't have tools. So it cannot recall the previous interactions. That's by doesn't have memory. And then it cannot perform actions. So it can take, it can make decisions, but it cannot take actions yet. So in order to have the full picture here, we have to have context and tools. And now we have a fully functional agent. Okay, it's pretty much the same, but something which is not very visible here, it's the fact that the round trips to the model is not only one. When we have tools, we may have multiple round trips, as long as the model decides it still needs to resolve some missing pieces of the big puzzle of the final response. And a few words about the context. The context can be the previous interactions, as I said, the chat history, or it can be any memory repository like a database or a RAG system, RAG being Retrieval-Augmented Generation system, which can store large amount of data. Or why not? Very simple, immediate, more text in our prompt. But this is not advisable because probably not all the context will be used. So then more advanced techniques are very useful here, like RAG. I will not get into details because it's not the scope of this talk. Let's go to Ollama. What is Ollama? It's a server which helps us with self-hosted models. So Ollama is a desktop application which wraps up large language models, or better, small language models. I will tell you in a bit why we have two names for this, and exposes this model with a HTTP interface. So it's pretty much a service. Why I have in the title small language models? Because it's agreed models which are less than 10 or 20 billions are considered small. And then being small, we may have a chance to host them on our own machines like I have today. So of course, we can run this server on CPU, but it's not advisable because it will take very long to respond. I mean, it may take like 10 times more time to complete a chat completion. So definitely you will need GPU. The more, the better. So first, when we try to build an application, we have to choose a good model. Probably the easiest way is to visit Ollama library online and to choose a model which fits best your needs. If you plan to do some simple chat completions, then you can stick to a small model, like much smaller. Like, for example, Llama 3.2. It's only 3 billions, and this fits in almost any NVIDIA card. For example, 8 gigabytes should be, it is enough. We can see here how much it will take from the memory, and of course some other things.
Daniel, let me ask you real quick. So you said that this is a small language model and it only has 3 billion tokens. what is where do we draw the line between what we consider a small language model and a large language model?
Well, it's not a general agreement on this, but the mostly if it's up to 10 billions, it's considered small. Well, I prefer to consider small anything which fits in my 16 gigabytes. So if
Yeah, that works.
If it's above, I cannot use. So from my perspective, it's not small anymore. Of course, there are some tricks to squeeze a model. It's called quantization. It's a technique to squeeze the model, sacrificing a little bit of performance, accuracy, I mean, and then it will probably fit better in your memory. And a few days ago, when I worked on the code repository, I realized the performance was terrible, and I started to investigate why. Because I used a model which was pretty close to 16 gigabytes, but still probably a little bit too much. So some layers were not fully loaded in the GPU, and this ended up in terrible performance. So I had to do some tricks. I will tell you how. For example, let me see. So let's discuss a little bit about this model. Let's go to our model. I have used Mistral because for my use case, I needed a potent model which is able to extract knowledge. And then simple or smaller chat completion models are not good enough. In the same time, I need this model to support tools. And tools, it's not supported or not well supported by most of the models. Still, Mistral, it's supporting this. And I will go right now to Mistral small 3.1. If you can see, it's consuming 15 gigabytes, pretty much to my full capacity. And they said, still, I had terrible performance. So let's go inside here and see more details. It says it's using certain type of quantization. So if I'm able to find a model which does a little bit more aggressive quantization, probably I will go like in 14 or 13 gigabytes, and then it will fit completely in memory. As soon as I found such a variant, the performance increased like 5 times. And it's a difference if you have a processing which takes like a minute to reduce from 5 minutes to 1 minute. Another important aspect, it's of course, as I said, to support tools. So for me, the two challenges were to fit in my available memory and to support tools. Okay, then let me show you a little bit of code.
Before we jump into the code, I have a question because
Please.
I tried, but I wasn't having, my ratio of success wasn't great. So I just want to know if you did try. I know there's a way to take models from Hugging Face and then use them with Ollama. Did you try that?
Of course, this is, yeah, I hesitated if I should go to Hugging Face or not, but now, because you asked, my pleasure. So Hugging Face is it's like a large bazaar with models.
Yeah, because looking for models, there's way more models on Hugging Face, but it's also the far west. There's a lot of.
You're missing a T there on Mistral.
Thank
Yeah.
you. So I will accept these search results, but I'm interested in GGUF format because safe tensors, which is the not native format for these models, it's not supported by my Ollama server. What is supported by my Ollama server is GGUF format, which is a general unified format something, I don't recall. So I will hit this button and then I can see a lot of places in this large bazaar, and I will go to the first one. Of course, we may have here important details most of the times, how we can use it, how we can download it, but don't spend much time. Simply go to files and choose what fits best for you. And as I said before, the Q4, this was the guy. So this was a little bit too much. So I have uploaded, I have downloaded, sorry, something from Q3. And this is much smaller. And let me show you how it looks after I mount them in my Ollama server. These guys here are some variants of models, bigger or smaller, but for sure I kept those who fit in my memory. In order to import here a model, you have to download the file, and then you have to prepare. I will show in a bit.
Some kind of manifest, right?
Some kind of manifest. It's called model file. In a bit. Okay, I recall where it is. Okay, and now voila, I have here total commander, which always betrays my age. So
I don't know what you're talking about. No idea.
yeah,
You're probably younger than us, Daniel.
so this is one of these files which I just, let's assume I just downloaded it, and then I have this manifest file, which is it can be simply only this first line, but, and that's, here is the catch. I was not satisfied with the default values, so I tweaked here a few parameters like setting the maximum number of GPU layers. If I put this to 99, then I made sure Ollama will use as many as possible. Ideally, all the layers, each model has a certain number of layers, and we want all those layers to be offloaded to GPU. This is the term, offloaded from CPU to GPU. So after investigation, I realized my model from Ollama library offloaded 45 out of 47 layers. Only for those last 2 layers, I lost like 5 times of the whole performance, total time for running my tasks. So you can investigate this if you look in Ollama server logs, and then you will see there a message saying not all the mod layers were offloaded to GPU, and that was the problem. So after I have downloaded manually a model from Hugging Face, I have prepare these parameters, making sure the GPU it's as a larger number. And after mounting this model, I realized, oh, but this model does not support tools. Then I investigated even more, and I realized I have to borrow the template from Ollama server. You can find it right here. Let me show you because it's important. I spent 2 days I have downloaded, uploaded all the drivers, all CUDA libraries, and after trying to think a little bit, I realized, oh, let's investigate these GPU layers, and that was the problem. So here you can see some default parameters, but you can override these parameters with yours, the system prompt as well, and the template. Because the template says here something about tools, tool calls. This is the guy. If it has this, it will support tools. Otherwise, is not. So why I'm saying that? Because the original model, which was not squeezed in at all, it supports everything. But by quantization, some quantization techniques can simply ignore these templates, and then you lose tools. And then simply the model does not support tools. It's a simple chat completion model. And this is the case pretty much with pretty much all Onyx models in Onyx format. Most of the times they lose the tools feature. And I don't like that because I need smart models. Even if it's on my machine, I need models which are able to become agents. If no tools, it's not an agent. Okay, and having this, all we still have to do is to run an Ollama command, pretty much like this. Ollama create, you can give it a name and call the previously prepared model file. And then you can see it in your local Ollama list, as I have here. Okay, saying that, we have now a model which fits in my memory, and it uses all the GPU layers. Therefore, it has a decent performance. So I will go to the code, and I will show you. Okay, so these are the models. Some of them are fast, but not very accurate. Some other are, because I have here 2 Mistral versions and with different kind of quantizations. Some are breaking tools. They support tools, but doesn't work good with tools. Instead of calling the tools, it's just spitting out a call in, it's responding with the JSON. But what I want, obviously it's messing up with the tool schema. So first, I will not run the Ollama client. Instead, I will run the OpenAI client. Why is that? Because I want to show you where do we want to get. Okay.
And while that's compiling, or actually, I guess it already compiled. I was just going to ask you real quick. Your comments earlier, the comments that you had in the code about the different parameters for Mistral. We had a question a little bit earlier in the chat when somebody saw that you were looking at Llama 3.2 on I forget where you were looking at it, but the audience member had a question about, like, is it good at actually following formatted input? And he said that he tried 5.4 mini instruct, and that it just fails. It just falls on its face when it comes to like tool usage and returning valid JSON. So I noticed that only one or two of those collections of settings you had for Mistral was like, oh yeah, this will work with tools. The rest of them were like, okay, this is going to break tools. So like, do you find like these small models are useful for tool usage and things like that, or like how do you get them to? Is it just a question of throwing more memory and bigger models?
Well, from my experience, the models below like 12 billion parameters, even they say they support tools, it's terrible. So why I'm saying that? Because now it depends what you agent want to do. Because if the agent wants to do something which is pretty much intensive in terms of thinking, like extracting entities, then a small model will simply miss a lot of entities. It will do a partial job, not decent at all. But if you go to larger model, then the performance will get slower. The models will get slower. Larger model in general are slower. Not to mention that the GPU layers of loading thingy, which I mentioned before. So what I recommend is to prepare some integration tests. More precisely, you can use now Microsoft.Extensions.AI.Evaluation and have some regression testing with this, and to check to assemble like your own benchmark to see which models are breaking and which models are fast enough or accurate enough. But to respond to the previous question, Llama 3 point something, well, if you try to do something which is not very intensive, I mean, for example, it will do something like classification. Classification is not very thinking intensive. Then by mixing the classification with the tools which the model is able to call, this scenario will work. But if you want to do something intensive and with tools, small models will be terrible. So the more you go for a larger model in terms of what memory you have available, the better, but you have to find the sweet point. Okay, what happened here? Let me run again because I missed something.
Yeah, Kane made the code crash. It's always happening.
Sorry, my bad.
Okay, so I'm calling this. I run again. Oh, I recall. I have this demo in 2 steps. So now it's okay. Using OpenAI or Azure OpenAI, it's pretty fast. Let's see what it should happen ideally in the scenario where we use small language models. This will not happen, but to see how far can we get. And let's go step by step. Let me show you what happened here. A few words about the conventions. Green is the input or partial output. Blue is the tool calls. the tool call, and the tool response as well. And yellow at the end, it's the final response. Now, saying this, let me show you. What we have here, it's the input, which is a synthetically generated email. But you know what? Let me get through the slides, because this will be much better to prepare for the demo. So what we want to do is to extract from this synthetic email entities and relationships. And for that, I have a workflow, a sequential workflow, which works in 3 steps. First step, or the entities agent, will get the query, and it will spit out the found entities. In order to do that, we'll use tools to read the entities ontology. Entities ontology, it's nothing else, at least for our case, nothing else than the definition of the entities in order for the model to understand what it's looking for. Then the second step, it's extracting the relationships. For that, we need to, again, the input query. I had to put here query. It's query, raw text, same thing. And to feed back in the entities. And the output will be, now I found. Sorry for this, but I need it. So it spits out the relationships. And then the third step, it's input entities and input relationships, and building up a graph. And Mermaid is good at representing different kind of diagrams, including graphs. These are the objects which, in my case, I try to identify, entities, person, organization, event, temporal, and location. And these are some relationships between the previous entities. For example, a person can work for an organization. An event occurs at temporal. An event is located at location, and so on. And then I have some input, and I want this. I want to identify valid entities from my ontology as provided at the runtime. And the final output, it's the Mermaid graph, which is mixing the found entities, which are represented as nodes. And then the edges are the relationship between these entities. So ideally, what we want to produce, it's a logical dependency between the entities in my email. For example, Elena participates in Amsterdam Tech Conference, but as well, James participates in that. And if we go back, we will see, hi, Elena, follow up for this event. It was great meeting you at Amsterdam. So obviously, these guys are connected somehow. And this is the diagram of the relationships between them. Now I will go back to the code, and I will show what we produced. This is the input. Then the agent calls a tool to load the entities ontology. Entities ontology is, as I said, a description. It's a dictionary, name, description. What's a person? What's an organization? What's a location? And so on. In the same time, similarly, we have relationships ontology. What this works for? A person is employed by or affiliated with an organization, and even a small example would help. So these are the ontology files. I want the agents to load them at runtime by calling tools. Now the question is it possible to simply dump tools and populate this extra context in the agent? The answer is yes, but then for what do we have an agent? I try to exemplify here. The agent can gather the necessary information at runtime via tools. And then let me finish this. Then this is a first produced partial output, which is the entities. Then in step 2 kicks in the relationship agent, which again loads its own ontology for relationships, and then it produces another JSON with the relationships. This, along with the previous collection, is enough to build up a graph. And the third agent does that. I call this agent diagram builder. So this is the produced graph which mixes the entities and the relationships. Now, another question, I ask myself questions. Another question, is this the ideal solution? Well, probably, for sure not. Why? Because as soon as we can do it without AI, it's better because it's deterministic and it's fast. But for learning, it was good to ask an agent to assemble, to probably, especially to exemplify what an agent can do. So let me show you how this looks.
Hey, Daniel, can you zoom in on your browser just a little bit for us?
To use what? Sorry.
Can you magnify your browser just a little bit for us?
Of
just
course.
Like Control plus.
Perfect. Yeah. Here, but here as well.
Perfect. Thank you.
Sure. So what we have here, it's the produced mermaid nodes and relationships or edges, and then we have them rendered here. And of course, we have again Elena, James Cooper, and Dr. Michael Anders. So obviously, our agents can do the job. But again, this was using OpenAI. Actually, I used GPT-4o model, which is pretty capable. But let's go now to a small language model self-hosted in my Ollama server. And let's see what it can do. Because as we can see together, not everything is ideal here. This will take like a minute, but still it's generating like more than 5 tokens per second. We can see it's able to call tools. This is the response from a C# method. So it's using tools. And then the other agent, relationships agent, tries to extract relationships. It's not obvious here but all the partial outputs are shared between the agents. So this is how the relationship agent knows about the previously extracted entities. And the same diagram builder knows about the two collections, entities and relationships, and it produces this mermaid. Now, this mermaid will not be the same as good, but not bad. I mean, it is good, pretty good. But as I said, as soon as you sacrifice accuracy and you choose a not so good model or a smaller model, for example, Mistral 7 billions or Llama, then this will degrade to terrible. Probably it will use tools, but it will not capture more than a few entities. Not to mention relationships, which is the next level of complexity. Relationships, it's even harder to extract because it considers not only the raw text, but the previously found entities. And saying that, let me show you how
can we compare the output real quick though?
Of course.
So this tab is the one that you just did locally in Ollama, right? With the Mistral model.
Correct.
Right.
And let me zoom out a little bit and exploit this space.
Okay. So it looks like Mistral missed some of the entity relationships.
Yes. If we look here, we see 23 lines. Here it was 26, but that's not all because Mermaid is able to combine nodes with edges, so that's not relevant all the time. Nevertheless, Mistral was not as good as GPT-4o, but close. For example, if I choose a model which has a more aggressive quantization, the more aggressive it is, the more entities I will miss here, or relationships. And it's not uncommon to obtain 0 relationships. Well, if you want to go with even smaller models, then get rid of tools, put everything in the input, like the ontology, along with the input, and you can go like this, and still you can get decent results. For example, Gemma 3, it's another model which works very well on. It's too important not to help the audience to recall this. Gemma 3, it's another good model which works very well on one GPU or on your machine, and 12 billions, it's pretty capable. It has 4B, but I advise 12 billions. This is pretty fast, and it's faster than Mistral. But as I said, it's important if it has all the capabilities we are looking for. And we don't see here tools. Gemma does not support tools. For example, Llama 3, it supports tools. 8B, it's a good way to go, but it's not so good at extracting the relationship. We can exemplify, but I don't waste too much time because I want to show you one more thing. So let's go back to the slides. So what we have here, it was a sequential workflow, but I want to show you something more. And this is a group chat workflow. When we get this mermaid diagram, most of the times, especially when we work with small language models, the diagram is either not complete, or either the syntax is broken. So what we do here, we'll use this workflow to validate the diagram. So we have two agents. It's the validator agent, which gets the mermaid, and it gets the two collections with the entities and relationships, and it will respond with an approval or with a list of errors or suggestions or corrections. And the diagram corrector agent will get, again, the mermaid, the entities, the relationship. The context will get shared by the workflow, and it will get the error list, and it will output a new mermaid diagram, hopefully this time a better one. When these two agents agree that the diagram is now correct, then the validator will approve, and then the result will be spit out in the final output. Let me show you how this works. In order to do that, we have agent framework. We didn't even scratch the entire surface, but let me explain you what I did, and ideally what this should be done. So in the meantime, I will run this because it will take like 2 minutes to run. So I activated the second workflow, which is the group chat. And then what I did with the first flow, I have converted it in a singular agent. So the previous workflow, which I have exemplified a few minutes ago, it's wrapped up in an agent, and then I simply get that agent and produce a result. The result I feed in the second workflow, which is dealing with the chat group. Now, here, a suggestion for improvement. Instead of having two disconnected workflows, one is the sequential workflow, the second one is the chat group. Instead of that, we can have custom workflow where we can assemble ourselves the workflow, the steps between. For example, instead of having a sequence, and after that, instead of having a collaborative graph, instead of that, we can have a sequence where the very last node, it's a collaborative group of agents. The same time, we can put on top, instead of having one agent which extracts entities, we may have in parallel to run concurrently two different agents, one extracting text, the other one extracting from text, the other one extracting from image. Because these models, probably they are vision models. For sure, Mistral is a vision model. So we can extract in the same time from a document which has a mix of text and image. We can extract in parallel knowledge from both, and then we can intelligently merge the findings. And that, as you can notice, we can have not a known pattern like sequential pattern or chat group or some other kind like hands-off pattern, but we can create our own pattern. And this is the recommended approach because agent framework is capable at doing this. But as I said, it's the next level of improving this code further. So let me run this. I should have run this again by now. I can take questions in between. So the first phase, it's not very chatty. It will run as an agent. And then the output will be captured in a variable and passed in as input for the other flow, the chat group. We want to see this. But very soon, we will see the output. And very soon, we will see the two agents debating, agreeing for a better mermaid schema. Because most of the times,
I was just thinking about how so we're used to thinking in terms of like interior architecture, like you have a UI layer that does UI things, and you have a business logic layer that does business logic things, right? This kind of reminds me of that, right? You have different agents who have different jobs, and like you just expect them to talk to each other and sort it out, which is kind of wild when you think about it.
I think the first approach, I mean, which we can use thinking on these agents is to think of them like microservices. Not entirely a microservice, but many similarities, because they again are domain specialized, and again there are multiple ways of orchestration and exchanging information in input output. And for example, agent framework comes with advanced orchestration. In semantic kernel, what we had, it was more like choreography, because the agents were responsible to plan. But here in agent framework, we have deterministic steps provided by the workflow. Still, inside group chat agent, we have choreography. That's why we will not control precisely the stop condition unless we build a proper manager which deals with the communication. For example, round robin can be set with a certain number of steps, but then in order to make it stop when one of the agents responds with a certain string sequence, then we can capture that sequence and force a stop. But here I had to go with the first and simpler approach, letting the agent decide when to stop. Let's see what we produced here. So this is the input. Entities, relationships, and let me paste too many screens. Okay, I found another session here. actually, this diagram, it was just on time. This diagram is corrupted, so it has an error somewhere. No diagram. No, it was me. Sorry. I missed the prefix.
Yeah, that specified the type of the diagram.
Yeah.
Was the human in the middle?
Top bottom.
Pretty much.
There it is.
So what we can see here, Dr. Michael Anders, it's not linked to Amsterdam Tech Conference. So obviously the diagram was not ideal. So what we expect here, it's these two agents to chat and to signal improvements. I mean, the validation agent should suggest improvements until they are all addressed. Ideally. Why I say ideally? Ideally because this is very prompt dependent. I mean, you have to build good prompts in order to make sure what makes a good diagram and what to consider to fix the diagram. For example, you have to specifically tell the agent to look on the previous JSON collections to see which entities are missing, which relationships are missing, which are extra, remove the extra, and syntax on top of this has to we have to take care as well. Let me put the fixed one. I will minimize this and this. Okay, let's ignore the very last node here, there, and see how better is the fixed one. So we have here this group, and then we have in the right side Dr. Michaels. Ideally, well, still not quite fixed, but our steps, because I put 7 steps of exchanging data between these two agents. Obviously, they didn't finish, so there is even more work to do. But if I put 10 and run again, probably we may get this group together with the first group, which is an improvement. So as I said, and I will say it again, it depends strongly on these prompts, on these instructions, agent instructions. We have to explain what means a good diagram, some rules for building this, and to make sure we get a pretty deterministic answer. And talking about determinism, unfortunately, when we use tools, we cannot use structured output. So we have to sacrifice one. We cannot use in the same run tools and structured output, because when we force to structured output, then it's messing with the tool JSON response from the model. So at least this was the case with semantic kernel. I'm pretty sure it's the same here. So that's why I had to choose tools. Okay, let me go to one of these agents. See, I actually response for me. So I cannot use something like this. Not as far as I'm using tools. So I have to choose. Of course, we can have more models, agents, but the more agents we have, the more the time to complete the task. And I will go back to the slides. Okay, that was it. I think we are 2 minutes over the agreed time.
That was a fantastic demo.
Thank you.
Yeah, I like the debate between the agents for the mermaid diagram. That was cool.
Yeah.
It looks like we lost Myra. Myra's frozen, so we are over time, and I'm just going to take over as the host. So I want to thank you, Daniel, for coming on and sharing that with us. It was really interesting. Really appreciate that. To our viewers, thank you for joining us. Thank you for letting us run a little bit long today. Please check out our additional streams at what is it? It's dotnet/live is the URL.
Yeah.
And I don't know who we have. Do we have anybody next week?
Yeah, we will continue. We'll continue the agent framework talk now with Vic Burdena, who will talk about building real world AI agents with agent framework. So we'll continue on this topic.
Cool.
We are all in with agent framework, right?
Yeah, it's the hot new thing. So we gotta talk about it. Thank you so much. And
thank you.
I'm sorry for my audio issues at the last minute. Thank you. See you next week.
Just time.
See you next week, everybody.
Bye bye.